Welcome back to the video. We're going to be doing 2023 June question number 5 and question number 18. Question 5 tells us two forces form a Newton's third law pair. Which of the following statements is not true? So for Newton's third law, the forces must be in same magnitude, opposite directions, they must be acting for the same amount of time, and then they must be same type of force, and they must act on different bodies. So A is going to be the answer because it's not true. It's the same object, it's going to act on different objects. This is wrong. These three are correct. Okay, so it says a student inflates a balloon. She uses a peg to keep the balloon closed. She then attaches a straw to the balloon using sticky tape. She passes a string through the straw and then pulls the string tight, as shown. The student removes the peg and the air leaves the balloon. The velocity of the balloon increases from 0 to a maximum. Explain how Newton's three laws of motion apply to the motion of the balloon during this time. So, firstly, what you got to identify here is the velocity is increasing, so there's going to be acceleration. Okay, so it's going to be acceleration here. Next point, very important, that you have to identify is maximum velocity. Remember, whenever they say things like maximum velocity, that pretty much means that forces are going to balance out, right? So forces are going to balance out and you're going to be traveling at a constant velocity or terminal velocity. That's basically what this means, right? So those are some of the things you should spot. Okay, so let's start by understanding what's going on. So as soon as you remove the peg, the balloon exerts a force on the air. So this is force on air, and the air exerts a force on balloon. Okay, right. So these are going to be opposite directions, equal in magnitude, same time, same type of force, different bodies. So this was a force on air, force on balloon, and this is going to be backward, and this is going to be forward. Okay, so that's Newton's third law. Okay, so you're going to mention that, and you're going to say they both are equal in magnitude and opposite directions by Newton's third law, right? So you're going to explain that stuff right there. Okay, make sure not to just state the law, but connect it to the question. Okay, next we're going to relate it to Newton's second law, and we're going to talk about acceleration here. So along with the forward force, there must be another force, which would be the resistive forces. Resistive forces. I'll tell you why this is important, okay, later on, but it has to do with the maximum velocity. Okay, now the forward force is going to be greater than the resistive forces. Why, sir? Why should the forward force be greater? Is because the question tells us that the velocity of the balloon increases, which means it must accelerate forward. So the forward force has to be greater than the resistive forces. So we can say the forward force minus the resistive forces is equals to ma. So there's acceleration and the velocity increases. Then what's going to happen is the forces will change. Now how they change, why they change, that's not required, but the forces change. Okay, until the forward force is equal to the resistive force. What's going to happen then is the acceleration will be equal to 0, the velocity will be constant or terminal, and the object will move with maximum velocity, right? And that's why we really emphasize this word maximum here, because this tells us that there must be opposing forces, right? And then when both the forward and the opposing resistive forces are equal, the acceleration is 0, the velocity is constant. And that's Newton's first law, right? So that's kind of how everything will work in the answer when I write it down. And this is just a bit of an outline of the answer. Okay, so I'm going to write it down now and hope this clears things up. Okay, so we're going to write down the balloon exerts a backward force on the air By Newton's third law, the air exerts an equal and opposite force on the balloon. The forward force is greater than the resistive forces. So by Newton's second law, the balloon accelerates due to the resultant force. Now, what's going to happen is that the magnitude of the acceleration is going to go down, because as velocity increases, the forces are going to change and they're going to start to balance out. So as they start to balance out, the resultant force is going to go down, so the acceleration is also going to go down, and they're going to start to become closer and closer to zero. And then eventually, when the forward and resistive forces are balanced, then by Newton's first law, force is zero, resultant force is zero, the acceleration is zero, and the balloon travels with constant velocity, terminal velocity, or maximum velocity. Okay, so that's going to be your answer. Okay, so do not do these things when you're writing the answer to this question or these type of questions. So saying the mass decreases as air leaves the balloon, so acceleration increases, is not correct, because the acceleration is actually decreasing to zero as implied in the question, because the velocity increases and then reaches maximum. So that will mean that the acceleration decreases to zero. Okay. Along with that, is there any other thing here? No. So don't mention this point. Next is going to be, do not simply state the laws. All you gotta do is apply them. It's in the question as well. Go back to the question, see it. It says apply the Newton's laws, not state them. Okay. Next is do not use terms like push or pull. I hope you're familiar with that, because those are IGCSE terms. In your levels, we want to be more technical. Say exerts a force. Okay. Last part is when you're talking about Newton's second law, talk about the forces that are acting. Forces like weight, drag, tension, forward force, resistive force, and tell which one is greater than which. And then talk about the resultant force and the acceleration. So these are just a few things to keep in mind. I recommend, after I show you a practical video of this experiment as well, like around 30 seconds, at the end of the video there's going to be the examiner report. Go through that, very important. Okay, along with the mark scheme, examiner report is equally important. You'll get a lot of insight from there. Okay, that's all. Now I'm going to show you a video and then go through MS&ER.
When I release my fingers, air pushes out of the balloon. That's our action. Our reaction is that the balloon moves with the same force in the opposite direction. If you want to learn more about Newton's third law of motion or ask me a question, check out scientistseason.com.